Hi everyone, Miss Phelan here, coming up on one of our last lessons of the school year. In this little mini unit, we've been learning about rocks. Remember, there are 3 types of rocks: igneous, which form from lava or magma cooling and hardening into rock solidification. We've learned about sedimentary rocks, which are made from tiny fragments or pieces of rock called sediments that are cemented together. And the last type of rock we are going to learn about are metamorphic rocks. Let's figure out more about this word metamorphic. You may have heard the word metamorphosis before. Metamorphosis means to change, when you completely change and turn into a new thing, a new being maybe. We often use this word. You may have heard this word when you learned about butterflies in 7th grade. You may have learned about the process of metamorphosis. Butterflies start out, they hatch from eggs. They start out as caterpillars. And as their life goes on, they eventually change from a caterpillar to a butterfly, right? The caterpillar and the butterfly are 2 totally different organisms because the caterpillar underwent metamorphosis to change from a caterpillar into a butterfly. Metamorphic rocks do the same thing. A metamorphic rock is when you have one type of rock and it undergoes a change and changes into an entirely new type of rock. How do metamorphic rocks form? Inside the earth, underneath the earth's surface, rocks may be exposed to heat and pressure. Remember when we learned about the interior of the earth? We said inside the earth it is really, really, really hot. The deeper you go, the higher the temperature gets. And as you move farther into the center of the earth, there's also more and more pressure, right? Think about applying pressure to something. The deeper you go into the earth, the more pressure there is on those rocks. So that intense heat and pressure inside the earth will change or morph an existing rock into a new type of rock. One thing that's often confusing for students is that they tend to think that the rock melts and becomes magma and then becomes a new type of rock. When metamorphic rocks form, they do not melt, okay? There is no new magma. They do not melt. The rock stays as a solid and changes into a new type of rock through a process called recrystallization. So these rocks do not melt. They recrystallize when exposed to heat and pressure. Okay? What does this recrystallization mean? Well, inside of the rock, there are different atoms, different minerals, different crystals, and originally, they may be oriented in all different directions, like you see in this picture here. If these are crystals or atoms in the rock, they may be oriented in all different directions. And when you add pressure to this rock, maybe there's pressure coming from this way and pressure coming from that way, and you smush it together, those crystals reorient themselves so that they're all facing the same direction as you see here. Notice that these lines are now all facing the same direction. That's from that pressure. This is the process of recrystallization. Again, like we just said, crystals are squished and recrystallize. The crystals that make up a rock are squished and recrystallize. This creates what we call foliations. Foliations are these bands that you see in the rock. I kind of think it makes it look like a marble cake. If you've ever had one of those marble cakes with chocolate and vanilla cake inside, and it creates this kind of marble-like pattern with the wavy lines of chocolate and the wavy lines of vanilla. It kind of looks like a metamorphic rock to me. These foliations are these lines of crystallized bands, okay? And that's how we can identify a metamorphic rock. One thing to know is that the foliations can sometimes look like bands or layers, but they're not quite layers. They're different than the layers we talked about when we talked about a sedimentary rock. These are two different processes. So remember that metamorphic rocks change from when you have one type of rock and it changes into a new type of rock. So, for example, we can look at this chart from our ESRT, okay? We are going to start out learning about metamorphism by thinking about the rock shale. Shale is a sedimentary rock, okay? We talked about sedimentary rocks the other day. Shale is made up of tiny, tiny particles, tiny sediments that have been cemented together. So if we have shale, and that shale is deep inside the earth and undergoes a transformation because it is exposed to heat and pressure, that shale will then turn into slate. Just like a caterpillar will turn into a butterfly, shale will turn into slate. Now, if we have slate, this process isn't done. We could still change the rock again. Okay, so we could have slate. If we add more heat and pressure, then we get that slate turns into what we call phyllite. So we have shale, shale turns into slate, slate has more heat and pressure, and slate turns into phyllite. But we're not done yet. We can add even more heat and pressure and turn phyllite into a new type of rock. We can add even more heat and pressure. We're here at phyllite, we add more heat and pressure, and we turn phyllite into a type of rock called schist. And this isn't even the end game. We still have one more step to go. Let's say we're even deeper in the earth. It's been millions of years. There is more heat, more pressure. There is building pressure on this rock. Even more heat and pressure. That schist will turn into a rock that we call gneiss. It's a nice rock. So if we make a little chart, if this is the chart that's in your eCert, as you add more and more heat and pressure, okay, slate, I'll go on this side, slate turns into phyllite, phyllite turns into schist, and schist turns into gneiss. How can you identify a metamorphic rock? What are the observable characteristics of metamorphic rocks? Usually, for our sake in this class, we are only going to look for one characteristic, and those are the foliations that we talked about before. Remember, the foliations are these kind of wavy bands with distinct colors, kind of looks like a marble chocolate and vanilla cake. We have these foliations, these thick bands of crystallization, of recrystallization, thick bands of minerals that we call foliations. So let's go ahead and take some notes on metamorphic rocks to sum up what we learned today. So we said that metamorphic rocks are rocks exposed to heat and or it could be both or it could be just one, and or pressure. And they change into a new type of rock. I'm going to underline the words heat and pressure here because those are the important forces that help to create a metamorphic rock. Something important to remember about metamorphic rocks is that they do not melt. They recrystallize. Okay, let's make a little chart here then and just make a very simple chart with a few examples of rocks and how they change from one type of rock into a new type of rock. So let's make a chart and say we are going to start out with, oh boy. The sedimentary rock. And the name of the sedimentary rock that we learned about was shale. So you have a piece of shale. It undergoes heat and pressure. And it turns into a metamorphic rock called slate. And these are our metamorphic rocks. Then we have our slate. Slate undergoes even more heat and pressure, and slate turns into phyllite. Phyllite undergoes even more heat and pressure, and phyllite turns into schist. And schist undergoes even more heat and pressure, and schist can turn into gneiss. For our last bit of notes here, we had just one characteristic of metamorphic rocks that we are focusing on here, and those are the foliations. So if we wanted to draw a little picture of a rock with foliations, it might have thick bands of mineral crystals that are aligned. That's all for today. Thanks for keeping up with the hard work as you learn at home. I miss you all and hope to talk to you soon.